Hello, everyone. As promised, I just made a new playlist on CoppeliaSim and WeRep, which is the educational version of it. So this is a great software for education about robotics, and so I want to make a series of videos on this amazing software. Remember, the educational version is free, so you can just go ahead and use that. And before I jump into robots and show you how to simulate robots in this software, I want to create a few videos and talk about some important preliminary things. And then we're gonna look at demos with robots and everything. So the first thing I want to discuss in this video is the types of objects and properties of objects that you have here. So for instance, in this demo that I made, you can see two cubes. And when I start the simulation, one of them jumps on the other one, and I added a coefficient of restitution to them. And so when they hit, basically it is gonna bounce off of the object, right? So let's take a look. There we go. Okay, but does it always happen? No, I can make it such that this guy literally passes through the other object and keeps going down. Let me show you. Take a look now. There we go. Did you see what happened? Now look. You see, this object did not move. That object came and it did not really interact with this red block. It reacted with the floor, right? Let me show you again. Look. It reacted with the floor the same way that last time reacted, as if this object does not even exist, right? And here is another one, look. Did you see? It literally passed through this object and the floor and went all the way down to negative infinity, no interaction. So there are all sorts of scenarios that can happen for two different objects and this floor, depending on the properties of these primitive shapes. So here, that is what I want to talk about: static versus dynamic objects, as well as respondable versus non-respondable objects. So if you look at the documents, the user manual of the software, you can see the difference between two major categories. So a static object does not move, okay? A dynamics object, basically, or non-static object, it reacts to the forces from the environment, like gravity. So if an object is dynamic, you start the simulation, it is going to fall down. If it's static, it's not going to even do anything. The gravity will not affect it, as well as the force from any other object, okay? So it will not react to the forces dynamic object does. Now, what is respondable and not respondable? So respondable is when the objects basically influence each other during a collision. So if they hit each other and they apply a force to each other, would that force affect their trajectory, their motion? So if an object is respondable, yes, it will be affected, and the trajectory of its motion will be affected by the forces of collision from other objects. And if it's non-responsible, then basically the collision by other objects has no effect on it. Like you just saw, that the gray block dropped on the red block, but has literally no effect on that. So here are different scenarios that you can see. So in this picture here, the static objects have a cross in them. The dynamics objects don't. The respondable objects are red. So if you look here, this case, which is the most complicated case, is where both objects are dynamics and respondable. So if they hit each other, what's going to happen? They hit each other and then they bounce back, right? Like an elastic, basically, collision, right? But for instance, let's look at this scenario here. One object is dynamic and respondable. The other one is static. So when it's static, first of all, this doesn't move at all. This dynamic one that moves, because this object here is non-respondable, as you can see, it basically has no effect on the other guy, and this one has no effect on the non-respondable object. So basically, this acts like a ghost. You can literally pass through it without any effect, this goes just like if it's a projectile, it just follows the projectile path, no effect. But if the object is static but respondable and this object is moving, when it hits it, like a ball hitting the floor or the wall, when it hits the floor, yes, the floor doesn't move, the ground doesn't move, but since it's respondable, it applies a force to this dynamic one, so this is gonna go back. So you see, for two objects to hit each other and one or both of them be reflected back, first of all, both of them have to be respondable, and then at least one of them should have a motion, correct? So it's either this case or this case. Now you can see even this case, look, what is it? They are both dynamic. They are both dynamic, but one of them is not respondable. Because this one is not responsible, the collision force between them will not really be affecting their motions. So yes, they both move, but clearly the collision force will have no effect. You see that? Although they are both dynamic and one of them respondable, because one of them is not, there will be literally no effect. So only these two scenarios are the ones that correspond to real life. These other ones are the scenarios that are simplified and where the object is not affected really by a collision force, which is not realistic, but many times you don't really want to simulate that collision, so you make the simulation simpler. Okay, so let me show you how to do that. So here I have two cuboids, and by the way, in Coppelia, if you want to create those, let me go ahead and start them from scratch so you can see how I make these primitive shapes. So what you can do is simply right click here and use add, or you can go up here in the menu and access the same thing. So if I right click and say add, there are different types of things that I can add, from primitive shapes to joints to camera, light, dummy, and we're going to go over each and every one of them in future videos. But right now we want to look at primitive shapes, and there are planes, disc, cuboid, sphere, cylinder, capsule, and cone. And for simplicity, I go with the cuboid. So once I do that, here it is asking me for the X, Y, and Z dimensions. So let's say I go with 0.3, 0.3, 0.3. Okay, again, they can be different dimensions. They don't need to be equal. And then you see here, I have a density for it that I can decide, and then I can make the object to be dynamic and respondable, and I can change it later. So let's say I go ahead and make my first cuboid, right? So this is my first cuboid. And here you can see it in the tree, right? So you can basically go ahead and edit that, right? There are all sorts of things you can do about it. You can change the name of it if you like, double click on the name and then call it whatever you want, object 1 maybe. Just make sure you press on enter, otherwise it doesn't make any effect. So object 1, right? And then now if you want, you can go to object 1, double click on the icon of it, and you get this window. So now you can go here under shape color and go ahead and change the color, right? You can change the color here. You can change the reflection of the color, shininess, opacity. You can change anything you want. So here, let's say I want to go and make it blue. So I keep the RGB value blue all the way up and red and green minimal. So I make my object fully blue. Again, I can make it opaque or anything, but let's say this is good. And then you can see there are all sorts of things about the faces. I can add texture to it if I want to, okay? Right, so I can, for instance, pick a texture from existing textures. If there is anything, I can do that, or load anything. There are all sorts of things you want to do, but right now the goal is really showing you these dynamic properties, and then under objects, there are a bunch of things that we want to see. So if I go under dynamic properties, this is where these two important things are. So here you pick whether the object moves or not, dynamic or static. You can see the mass of the object, okay? And you can see the inertia matrix for it, the center of mass and everything. And here is where you can have it to be interacting with the environment or not, right? And then under object here, There are other properties that we're going to talk about later, including collidable, detectable, and measurable, which is going to be in my next video. And this is if you have a robot and you can look at the self-collision. So let's say this is my first object that I made, and now I'm gonna go ahead and bring in another cube here. By the way, you have here the view toolbar. So this is the camera pan, right? So you can basically pan into the object. And by the way, this is that texture we just added, right? So this is for pan, this is for rotating the scene. This is for zooming in and zooming out, although you can do it with the scroll of the mouse button. You can change the camera, and this one is one of the best ones, fit to view, okay? So if you want to fit to view, you can click on that. And then you have these two for manipulating the object, which I'm going to show you in a second. So let's add another cube here. So I right click again and say add a primitive shape. And I make another cube, again, probably the same dimension. And maybe a little bit different density. Dynamic and respondable, create that. Now you see this one is exactly on the top of the previous one. First, let me double click and change the name of it. So call it object 2. And then I want to move this object up and maybe change the color of it. So first let's double click and change the color to something different, maybe green this time. So I'm gonna make this guy green. There we go. And you clearly see it has the properties that the other one does, respondable, dynamic. And now I want to move it. So with the object selected from the tree, now I click on this guy to move the object. And here I can either move it manually by my mouse, and I can pick in which direction to go and about which frame. Do I want it to go about the work frame, or do I want it to go about the own frame, the body attached frame? So here I say maybe work frame, and I can say go only about the z-axis, right? And then I can grab the mouse and move it along the z-axis as much as I want. Okay, so this is one way. The other way, I can pick these guys and exactly translate or position it wherever I want. So let's say I want to exactly put it at 2.5. So just typing 2.5, enter, and there we go. So this is much more accurate if you want to exactly place it where you want to place it. So now it's right above it, 2.5 meters above. And now ideally, if I drop it, I should have a collision, right? Because both objects are dynamic. And this floor also counts as an object. So clearly, since they are respondable, this object cannot pass through the floor because there is force between them. There is a normal force. So this one will drop and then they hit each other. So there should be basically some kind of force sections, right? So look, when I drop it, you see that it doesn't really bounce back off of the other object, the blue object, and nothing happens. And you might say, well, what happened here? Didn't you make them both dynamic and respondable? Yes, but remember, we forgot to add one thing, and that was to add the coefficient of restitution. And so here, the solver I use is Newton, right? There are all sorts of Newton, so I use the Newton. Now here, I'll show you how to change the coefficient of restitution. So I go back here, and you see, by the way, this is my floor object, right? So if you look at the floor also, right, you see that the floor is respondable, but it's not dynamic. Why not dynamic? Because I don't want the floor to drop. I want it to be static, but it is still respondable. So if you leave an object on it, it's not going to pass through it. It is going to apply a normal force to it. You see, so the floor is an object that is already added. So let's go to these cubes. So double click on this object. And you might say, where is the coefficient of restitution? If you go here, you don't see anything, but there is this one here called engine properties. And if you go there, it has all different solvers here, starting with Newton, which is the one you chose. And look here, there is a restitution coefficient. So I use maybe 0.8, right? And there we go. Now this object has a coefficient of 0.8. And I double click and go to the other object, and I add another restitution coefficient for that one, maybe 0.7. And then here, now hopefully when I run it, it should be a real collision. So let's go ahead. There we go. You see? So clearly it dropped on it, it bounced back several times and then fell off, right? So clearly you see the collision here. So now you might say, how did you make this green box to pass through the floor and this blue cube and go all the way down to infinity? All you need to do is to make this green one be non-respondable. If you make it non-respondable but dynamic, the gravity will still act on it, but the collision force does not. So when it hits these two objects, nothing happens, so it keeps just going down. Let's take a look now. Here we go. You see, it just kept going down as if those two objects are not even in front of it. So that is what that is, because this one is non-respondable, so it doesn't matter if the other ones are. This one will not be affected, correct? Yeah? Now, if I go ahead and change the scenario, so I make the blue block non-respondable, but I make the green one respondable. So what's going to happen? Well, this time the blue box, as if doesn't even exist there, the green box will just hit the floor. So the impact will be between the floor and the green box, not between blue and green. Look, you see? And what happened to the blue? Because blue was not respondable, the normal force from the floor was not acting on it, so it just fell down all the way to negative infinity. So you clearly see different scenarios and what happened when you make an object respondable or non-respondable. And if you don't want this, let's say blue one, to just going down, you can simply go ahead and make it also a static object. As soon as you remove that checkbox, now the blue will not move, will not interact. There we go. Yeah. So hopefully this video was clear for you how to create a primitive object and what does dynamic static mean, what does respondable non-respondable mean. And one thing that you might wonder is, well, we have different kind of shapes in CoppeliaSim or in VREP. Why did they pick primitive shapes for collision? And to answer that, I would like to refer you to this page here, which is talking about different types of shapes, which I'm going to talk about in one of my future videos. So there are different types of shapes in CoppeliaSim, from simple shapes to compound to convex to compound convex to primitive compound and height filled shapes. And as you can see, the software user manual suggests that the primitive shape is best suited for dynamic collision responses. And you see, although there are these simple shapes, compound shapes, and so on, and the first two are not even optimized for dynamic collision, and this convex and compound are optimized for collision, but still it says it's recommended to use primitive shapes, whether simple or compound. Primitive shapes are way more optimized and suited, much better suited for a dynamic collision. So use these two kind of shapes if you want to do a dynamic collision. Okay, hopefully the video was useful to you, and I'm gonna see you in the next lecture. Thank you.